Due to the strange nature of class today, which had to be canceled because convocation ran long, I am making this video to cover that material. I would mention that the textbook should be pretty readable for this section, so you have both your textbook and this video as reference. Please let me know if you have questions over any of this before class on Monday. So what is the point of this material? I'm going to introduce our next subunit of material, which is about the mathematics of voting and elections, a very important topic. We'll look at two different methods to select the winner of an election, the methods of plurality and Borda count. So put shortly, given election data, there are multiple ways to decide who should be the winner and questions about fairness. Under a fair voting method, who should win? Questions like this. So that's what this unit is about, and today we're just talking about two methods, and then we'll build on this material on Monday. So the learning goals for today are, given some preference data, some election data, be able to calculate what's called a plurality winner, the person who wins under that method, and similarly for a different method called Borda count. So up front, I should note that we're going to be thinking about using different kinds of ballots in these elections in this section. So when you typically think about voting, you imagine going into a voting booth and voting for one person. So if you voted in the 2020 presidential election, for example, when you went to vote, you would say, I'm voting for Trump, or I'm voting for Biden, or I'm voting for some third-party candidate, whatever. So when you use preference ballots, though, you don't just say that. You don't just say who your favorite is. You provide a complete ranking of all the candidates. So using a preference ballot, each voter can express who their favorite candidate is, but also who their second favorite is, and so on, all the way down to their least favorite candidate. So a preference ballot allows each voter the chance to rank everybody. So if you want to see what such a thing looks like, the only state in the U.S. which uses preference ballots for presidential elections, at least right now, is the state of Maine. So here is what the presidential ballot in Maine looked like back in 2020. And you can see here when you vote for president, you can say who your first choice is, second choice, and so on. So if Biden was your favorite, you would bubble this in. And then if Hawkins was your second favorite, you'd color this in, and so on. So you can give a complete ranking of the candidates. So you can say, I like Biden the best, and then, Jorgensen third best, and so on, all the way down to you could say Trump is my least favorite, or vice versa. And the same thing is true of senator in Maine. So see the same sort of preferences here. So when the citizens of Maine vote for their senators, they cast a preference ballot. They can give a complete ranking of the candidates. Those are the kind of ballots we're going to be thinking about using in this section. Now, how will we display election data? Once everybody has cast their ballots, how do we look at the results? The answer is what your book calls a preference schedule or a preference table. Those are the same thing. Now, I should mention that textbooks in this area have their own language for some reason. So if I slip up, I might call these things a voter profile, because that's what the academic literature calls them. In popular discourse, like if you look at the websites of actual election boards or whatever, they call these things cast vote records. So I might call them any of those three things because the language gets jumbled in my head. So suppose there's an election with four candidates, A, B, C, D, who have these four names. And imagine these are like, I don't know, mayoral candidates or candidates for some sort of position, whatever, and people have cast their ballots. So remember, voters are casting preference ballots, so they're giving a ranking of these candidates. Here's how we're going to display the results. So each column of numbers corresponds to a different way that people felt about these four candidates. So for example, see the number 30 down here? I can't highlight it individually. But that number 30 is telling you 30 people ranked Branson first. So 30 people liked Branson the most, and those same 30 people liked Avalon second, those same people liked Columbus third, and those same people liked Dunkirk fourth. So these 30 people all were in complete agreement on how they would rank the candidates. All 30 people liked Branson best, all the way down to Dunkirk least. These 24 people liked Dunkirk the most. Then they liked Avalon second best, Columbus third best, and Branson last. So these 24 people don't like Branson at all, whereas these 30 people like Branson a lot. So a bunch of people voted in this election. This is the most concise way to show you the election data. You could imagine me just showing you all the individual ballots, but that would just take up too much room on this slide. So this is the most compact way, this kind of table. It's the most compact way to show you how everybody voted. So now you have a complete record of how each voter ranked the candidates. So the first thing you should do when given something like this is just do some questions that check whether or not you've understood what this table is telling you. So if you cannot read tables like this, the rest of this unit will go very poorly for you. Now, it does take some getting used to read these tables. So we're going to start with questions like this. And obviously, if we were in class, we would just do these together. But let me run through them now. Given a table like this, you can tell the size of the electorate. You can tell how many people voted. 30 people voted this first way, then 24 this way, and so on. So in total, 30 plus 24 plus 18 plus 12 plus 10 plus 6. In total, that's how many people participated in the election. And if you add those numbers up, you get 100. So the answer to the first question is 100. You can tell that by just looking across this bottom row. Now, let's think about how many voters liked Columbus the best and also liked Branson second and also Avalon third and Dunkirk fourth. So how many people felt that way? They ranked Columbus as their favorite, Dunkirk as their least favorite, Branson their second favorite, and Avalon their third favorite. Well, if you're going to think about voters who ranked Columbus first, here's Columbus's name. So these 18 people ranked Columbus first, as did these 10 people. So we're stuck with these two columns just by knowing Columbus was first. Oh, and then Branson second. Okay. So back over here, Columbus first, but Branson's fourth. Whereas in this column, Columbus first, Branson second. And then Avalon is third, and Dunkirk is fourth. So these 10 people right here are the people who feel this way. Columbus best, Branson next, next Avalon, next to Dunkirk. So 10. Okay, well, how many people like Branson the most? Columbus the second most, Dunkirk third most, and Avalon fourth most. How many people feel that way? Well, here's Branson first right here. Here's Branson first right here. So we're limited to those two columns. Oh, but these two columns, they both agree that Avalon is second. So these 30 people and these 6 people agree on the first 2 spots. All of them agree that Branson is the best and Avalon is second best. They disagree further down. They disagree about who is the least liked. But anyway, it turns out nobody feels this way. There's not a single voter who thinks Branson is the best, Columbus second best, Dunkirk third best, and Avalon fourth best. So the answer here is 0. So sometimes there's no voter that feels a particular way. Okay, how many voters ranked Branson first on their ballot? To answer a question like that, you find Branson and then find all the ones. There's a 1. There's a 1. So the people in this column here and in this column here, they all agree that Branson is the best. There's 30 over here and 6 over here, so the answer is 36 to this. How many voters ranked Avalon first? Well, if we go to that candidate's entry, 2, 2, 2, 2, 3, 2, not a single voter ranked Avalon first. So you can't find a voter who says Avalon is my favorite. So the answer to this question 5 is 0. One last question about interpreting these tables. How many voters ranked Branson last? So here's Branson. So these 24 people rank Branson in 4th place, as do these 18 people. So that's 42 total people. So Branson is a polarizing candidate, if you like. 36 people, 30 from here and 6 from here, 36 people like Branson, really like Branson, but then 42 really don't. So more people hate Branson than really like Branson. These 42 people here say no thank you to Branson, least favorite, whereas these 36 say that Branson is their favorite. Okay, so once you can read a table like this, now it's time to move on to methods of electing winners. So the question is, if I just plopped this data down in front of you and said, who should win? Should Branson win on the strength of their 36 first place votes? I don't know. So we're going to think about methods for deciding who should win. So the first method we're going to think about is what we normally think of as the usual voting method. So again, if you're usually voting in, say, a governor's race or a mayoral race, you're just saying which candidate you like the best. You say one candidate's name, and that's presumably your favorite candidate. So back up here, these 30 people, if you said, well, I don't care about your preference data, don't give me a preference ballot, just tell me who you want, just vote for somebody. Presumably, because Branson is their favorite, they would vote for Branson. So these 30 people would vote for Branson. These 24 people, if you said to them, I don't care about your full preferences, just tell me who you're voting for. Give me one name. Presumably, they would vote for Dunkirk and so on. So plurality is just the method we're used to. It says, I don't care about any other choices, just whoever gets the most first place votes wins. And this is what we normally use, although without preference ballots. But if regular ballots in the US most of the time just ignore people's preferences. So plurality just does that also, ignores preferences. So if you go back to the table on the previous page and count up, Avalon gets no first place votes. We've seen that. All right, no first place votes. Branson gets 36 and so on. So what happens is plurality says Branson and Dunkirk are tied. They both got the most first place votes. So then you can run a tie break if you want to, or you can just say for now that these are both winners. But that's how plurality works. You just, for each candidate, count up how many first place votes they get, and then whoever gets the most, or the set of candidates who get the most, are the winner. So plurality says Branson and Dunkirk, you're the winners. Board account does something much different. It's a points-based system, and after I describe it to you, if you follow college football or something like that, this is the same kind of method they use to declare the Heisman Trophy winner. In baseball, they use it to declare a Cy Young winner, and so on. So this kind of points system is not unusual. And in fact, the idea of a GPA you can think of in this framework. But anyway, here's how it works. Suppose there are 3 candidates in an election, and those candidates are called A, B, and C. If a voter votes this way, so they say, I like B best, A second most, and then C the least, then that voter is just throwing points at the candidates. So a first place, what does it say? A first place vote is worth, in this case, 3 points. A second place vote is worth 2 points, and then a third place vote is worth 1 point. So each individual voter is giving points to the candidates in accordance to the ranking. And the number of points you get depends on how many candidates there are. So if there are 4 candidates, and if a voter casts this ballot, saying I like D best and C last, that voter is just saying, please give 4 points to D, 3 points to B, 2 points to A, and 1 point to C. So under board account, each individual ballot gives a certain number of points to each candidate. And then in the end, the candidate who gets the most total points is the winner. That's how that method works. So let me show you how this goes. So each candidate here is going to get a score based on how people ranked them in total. And so, okay, let's think about Avalon. So if you look across the table here, these 10 people right here rank Avalon second to last. And then the other 90 people rank Avalon second. So again, back here, a first place vote is worth N points, where N is the number of candidates. So in a 4-candidate election, a first place vote is worth 4 points. That's the most. Second place is worth 3 points, and so on. So 90 people say, I like Avalon second. That means they're going to throw 3 points that candidate's way. 10 people rank Avalon second to last. They rank Avalon third. So each of these 10 people gives Avalon 2 points. And if you add this up, you get 290 points total for Avalon. And then you just do the same thing for the other 4 candidates. So let's think about candidate B, so candidate Branson. How many people rank Branson first? We've already counted that, 36. This one and that one. So 36 people say, I like Branson the best. So each of those 36 people throws 4 votes Branson's way. And then 10 people rank Branson second. See that? So 10 people rank Branson second. So each of those 10 people is giving Branson 3 points. And then 12 people rank Branson second to last, rank Branson third, these 12 people here. And finally, 42 people just rank Branson last. So these 42 people here. And each of those people gives Branson 1 point. So if you add all this up, you get 240 points. So the fact that Branson is polarizing has hurt this candidate. They get a bunch of points here from those 36 first place votes, but then their 42 last place votes kind of bring them down. Because multiplying by 1 doesn't do much for you. Multiplying by 4 does a lot for you. So in the end, Branson ends up with fewer points than Avalon. So Avalon's strength in second place rankings, board account rewards them for that. Board account gives them 290 points. And here are the calculations for C and D. So for candidate C, Columbus, these 18 and these 10 people, so 28 people total, rank Columbus first. So there's 4 points each. 54 people rank Columbus third. These 54 people here. So rank Columbus second to last. So there's that 2 for second to last. And then 18 people rank Columbus actually last. These 12 and these 6. Okay, so if you do these calculations here, Avalon ends up with 290 points, Branson with 240, Columbus with 238, and Dunkirk with 232. So board account paints a much different picture than plurality. Under plurality, Branson and Dunkirk were the 2 strong candidates. One of them should win. But under Borda is saying, no. When you take people's preferences into account and you weight the rankings appropriately to where a second place vote counts for 3 points, then A, candidate Avalon is the clear winner, Borda says. So there's conflict between the 2 methods here. Do you think Branson should win? Do you think Dunkirk should win? Do you think Avalon should win? It depends on how you best think this vote data should be transformed into a winner. So part of what we're going to do later is think about how you compare voting methods. So board account, is that a good thing to do? Plurality, is that a good thing to do? How could you compare them? That's what we're going to do moving forward. Now to finish this off, this is the exercise you would have done in class. Here's a fresh new table. And I would have asked you to find the winners under both methods for this table. Now you can check, and you should do the work, but candidate C, Coachella here, that candidate is the winner under both methods. So all of that to say, for some elections, like this one, these 2 methods contradict each other. These 2 methods disagree. But in other elections, they agree. So in some elections, there's just kind of a consensus candidate. There's kind of a strong candidate, and that candidate will rise to the top no matter what voting methodology you do. But in other elections like this, there's not really a clear winner here just by looking at the data. So then the method you use to elect a winner will matter. So moving forward, we're going to look at more voting methods. In particular, we're going to look at the method that Maine uses. So remember, the state of Maine has people fill out preference ballots. So the state of Maine has data like this that they're crunching. They don't use board account to calculate a winner. They do something else. So we're going to look at that, and we're going to think about how you can think through strengths and weaknesses of voting methods, just like we thought through strengths and weaknesses of apportionment methods. So there's going to be some so the same sort of like cost benefit trade-off analysis with this kind of stuff. Okay, so at the end of this video, if I give you a table like this, you should be able to read it. You should be able to tell me who wins under plurality, tell me who wins under Borda. And we'll pick up with this on Monday.